Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about hydraulics. At ang ating magiging topic for today is all about hydrostatic force on plane surface. At magkakaroon tayo ngayon ng derivation ng formula at sa huling bahagi ng ating discussions ay mayroon tayong inihandang tatlong interesting problems para sa inyo para lalo nating maintindihan ang ating topic for today. Magsimula tayo with a simple discussion about the topic. At magsimula tayo sa isang case o liquid na kung saan yung liquid natin ay mayroong tinatawag na unit weight at ang kanyang magnitude ay equal sa product ng density niya at ng gravitational force. Okay? Assume natin that here is the water surface, the liquid surface, and on the liquid, meron tayong a plate that will be submerged. Assume natin that this plate is now submerged in the liquid at a certain angle with respect to the vertical or with respect to the horizontal. So assume natin na itong axis ng plate makes an angle of theta with respect to the water surface. Now, para makita natin mabuti kung ano ba yung itsura ng plate, imagine natin that we view it from this side, okay, mula sa side na ito, okay, down to the right, so that we shall be viewing the entire area of the submerged plate. So here is the submerged plate. Let us generalize the area, and the centroid of the plate is located somewhere here at G. Now, this G can be found on the plate, which is here. At sa ating derivation, mahalaga na maintindihan natin kung nasan ba itong kanyang position. Either we measure it along the axis papunta dun sa liquid surface or we measure it directly vertical towards the liquid surface. So, assume natin that the distance of this G papunta dun sa liquid surface measured along its axis shall be defined as bar Y. Ginamitan natin ng bar yung ating symbol because we wanted to designate that this location or this distance is measured from the centroid of the geometric figure or the plate. At pwede rin itong ma-measure vertically from the liquid surface. At tawagin natin yung kanyang distance ay bar H. Again, ginamitan din natin siya ng bar to designate that this distance is measured from the centroid of the plate that is submerged on the liquid. So we would expect that somewhere below this center of the area, there will be the hydrostatic force that will be exerted by the liquid on one side of the plate, and we will be calling it as F. Okay, this F will be acting at this point, which shall be called as the center of pressure. So this center of pressure can be found on this area somewhere here. Okay, here is the center of the pressure. Okay, gaya ng ginawa natin kanina sa centroid, okay, so it is also important that the location of the centroid be known. At tatawagin natin na yung kanyang centroid, okay, center of pressure, okay, mula sa liquid surface measured along the axis of the plate ay tawagin natin siyang Y sub P. The subscript P, okay, will denote that this is measured from the center of the pressure of the hydrostatic force. So pwede rin siyang ma-measure vertically from the liquid surface, and that distance shall be called as H sub P. Diba? Ngayon, ang ating magiging target ay makuha natin ano ba yung magnitude nitong hydrostatic force that would be acting on this side of the submerged plate. At para maunawaan niyon, mabuti na itong ating area ay subdivide natin into smaller differential area. So, kunwari, meron tayo ditong small differential area. Itong kulay blue na nakikita natin dito, no? Itong differential area, dahil maliit lang siya, will be subjected to a very, very small hydrostatic force. And we will be calling this hydrostatic force as differential force. Para ipakita itong ating differential area on this section of the area, so we try to project this area so that this area can be viewed here. Ito yung ating tinatawag na differential area. The differential area, dahil maliit lang siya, would have the center at this point, which actually is also at the same point where the differential area is being considered. At gaya nga ng binanggit ko kanina, this position is very, very important in the derivation of the formula. So tawagin natin na ang distance itong differential area as measured along the axis towards the liquid surface shall be called as AY. Yan, tawagin natin Y, no? Or its distance vertically from the liquid surface. Pwede rin siya tawagin, okay, H. At makikita natin na itong bar H, okay, bar Y, H sub P, Y sub P, H at saka Y ay mayroong relationship. Okay, and you can find that, okay, all of this, the ratio of the H to the Y is the ratio of the opposite to the hypotenuse of triangle, ano? Kaya lumalabas that sine of this function theta will be equal to the ratio of bar H to bar Y. At equal din siya sa ratio ng HP to the YP. At equal din siya sa ratio ng H to dy. At makikita natin sa relation na ito that H is equal to Y multiplied by sine of theta. Ganon din itong ating bar H. Kaya equal din naman sa bar Y multiplied by sine of theta. So, kung bakit ko pinakita yun, kasi mamaya may halaga itong ating relation between HY, bar H, and bar Y. Diba? Ngayon, tingnan natin, ano? Sabi dito, the differential area dA, this area dA, ano, of the submerged plane is subjected to a very, very small hydrostatic force dF. Due to the pressure exerted by the liquid where the plane is submerged, and the magnitude of that differential force is equal to P multiplied by dA. Ano ngayon itong pinatinutukoy dito? Ito yung tinatawag nating pressure at the point where our A is located. This is the pressure exerted by the liquid at the depth where dA is located. Now, if dA is located at a height equal to H, and this liquid surface has the following property, unit weight, which is equal to rho multiplied by G. Therefore, P will be equal to WH, which is also equal to rho multiplied by G multiplied by H. Kaya if this P will be substituted with the value in this formula, then our DF will be equal to, rho GH multiplied by dA. So, ang ibig sabihin to, itong differential area na ito is subjected to a very, very small force equal to the product of rho GH multiplied by that differential area. Kaya, if we will be taking all the forces acting on each differential area starting from the bottom up to the top, then, what do we have? Sabi dito, kung pagsasama-samahin daw natin yung differential force na nag-a-act dyan sa area na yan, na magsimula tayo sa ibaba hanggang sa dulo, ulitin lamang natin, ano? So, ulitin natin. Pakita natin that we can sum up all the forces, all the differential forces that are acting on the differential area, starting from the bottom up to the top. Therefore, what do we have? We shall be having this relationship. Okay? When we say summing up this differential force, it is actually equal to the integral of that forces. And this will be the summation of all those product will be the integral of the product of rho multiplied by G multiplied by H multiplied by the differential area. Di ba? Now, we're going to substitute this value of H na makikita natin dito, which is equal to Y sine of theta. That is H equal to Y sine of theta in this equation. Then our equation will become equal to F, which is the integral of the differential forces, shall be equal to the integral of the product of rho G times Y sine of theta dA. Itong Y sine of theta is actually our H. And we can take out all those constant. Rho G and sine of theta are constant. So we can take that out of the integral sign, and this becomes now equal to the hydrostatic force equal to the product of rho G times sine of theta times the integral of Y dA. Meron akong gustong ipapansin sa inyo. Saan na nare-recall nyo itong term nito? Do you still recall this term? Okay? Do you still recall the term? That the integral of YdA, kung babalikan natin yung ating lessons sa centroids of geometric figure, then the integral of YdA is actually the product of the total area multiplied by the distance of that area, of the centroid of that area from the reference axis, and that is called as A multiplied by bar Y. Now, if this term, the integral of y dA will be substituted with the product of a multiplied by bar y in this equation, then our equation becomes rho g multiplied by sine of theta multiplied by a times bar y. Diba? Ngayon, pagkasama-samahin ulit natin, if we will be rearranging this, then the equation becomes rho g times y sine of theta multiplied by a. But sana mapasin niyo that this bar y sine of theta is actually equal to bar h, di ba? Kaya nga sabi dito, but bar y sine of theta is equal to bar h. Therefore, if this bar y sine of theta, which is equal to bar h, will be substituted here, our equations becomes rho g times bar h times a, or simply this becomes equal to w times bar h times a. And this gives us the magnitude of the hydrostatic force exerted by the liquid upon the surface when the surface is submerged or immersed in it. Now, in this formula, how do we define the following? So, what is our rho? Our rho is the density of the liquid kung saan yung plane is submerged. While bar h actually refers to the vertical distance of the centroid at that plane from the liquid surface. At ito namang ating area is the area of the plane surface. Kaya kung meron ka ngayong object or plane surface na sinubmerge mo in the liquid, then that would be subjected to a hydrostatic force equal to the product of the unit weight of that liquid multiplied by the vertical height of the centroid of that area and the area itself. Now, it's also important that the location of this hydrostatic force shall be defined. So in our illustration, we are talking of where is it located? Where is CP located? So CP can be located by its distance from the liquid surface measured along the axis of the plane, and that is equal to y sub p. If we are going to consider an axis along the intersection of the liquid surface and the plane surface, itong axis na ito, yung the intersection itong axis na ito at saka itong liquid surface, which is this point. O ano? And if you're going to view it mula sa side nito, mula dito sa side nito, it will be this axis. Itong axis na ito. Di ba? It will be that axis. Yon. Now, sabi dito, if you're going to apply the principle of moments, maybe you can still recall the principle of moments. That says that the moment of the force is equal to the sum of the moments of its component. Hence, if this will be applied to this forces, we have the total force, the moment arm will be defined by sub P, and we have the individual forces defined by dF, and whose moment arm is equal to Y. Therefore, if we shall be applying it in that relationship, therefore, the product of F multiplied by Y sub P shall be equal to the summation or the integral of the differential force multiplied by its moment arm. Okay, i-recall natin yung differential force ay na-define natin kanina, and that is equal to rho g multiplied by y times sine of theta multiplied by dA. Samantalang itong f naman, na-define na rin natin, and that f is already defined to be rho g times bar h times a. Now, if these two will be substituted in that equation, then our equation will become equal to rho g bar HA multiplied by YP is equal to the integral of rho g times y sine of theta multiplied by dA multiplied by the moment arm y, which is this one. Now, let us try to analyze this part. If y and y will be combined, therefore we will have y squared. Okay? And if sine theta, rho and g shall be taken out of the integral sign because they are all constant. Diba? Therefore, what do we have? We shall be having rho g sine of theta times the integral of y squared multiplied by dA, okay, keeping the left-hand side the same. Now, let's go back. If we will be recalling, the value of bar h is equal to bar y sine of theta. Di ba? Bar y sine of theta. We will be recalling bar y sine of theta. You have bar y sine of theta is substituted to bar h. Therefore, we have rho g times bar y sine of theta multiplied by a times y sub p is equal to rho g sine of theta times the integral of y squared dA. And you will notice that in this equation, rho will cancel, g will cancel, also sine of theta will cancel. And I would like to recall, okay, do you still remember this term, that the integral of y squared dA. Now, pag-aralan natin, ano ba itong tinutukoy itong y squared dA? It actually refers to the second moment of area, okay, referred from the distance where y is measured. And since y is measured from this xx, di ba? Therefore, it refers to the moment of inertia of this area from the x-axis or from the intersection of the plane and the liquid surface. So that if this will be simplified, we can take the value of y sub p, or the distance. This distance will be equal to the ratio of I sub x multiplied by the product of a times bar y. So in this equation or formula, we say that y sub p is the location of the center of pressure measured from the liquid surface along the axis of the plane. This distance mula dito hanggang doon sa distance na yon. Samantalang itong I sub x naman natin is the moments of inertia with respect to an axis along the intersection of the plane and the liquid surface. While A is the area of the plane and bar y is the distance of the centroid of the plane, centroid of the area from the liquid surface measured along the axis of the plane. So, ganun natin kinocompute yung position. Kaya lamang, mapapansin natin, itong position na ito can also be defined by its distance from G. Nakita niyo yung G nito? So, if we are going to consider solving for the distance of the center of pressure from the centroid of the area, if this is the centroid of the area and here is the center of the pressure, we can also locate the center of the pressure from G by calling it as our E. Tawagin natin itong E. Diba? Eccentricity. Where E can be taken by looking at this illustration. You will find that y sub p is equal to the sum of two quantities. You have bar y and you have E. And so you can find that y sub p is equal to bar y plus E. And since we are working on E, therefore E can be found to be y sub p minus bar sub y. Diba? Now, tingnan natin mabuti. Okay, kanina nasolve natin itong y sub p, di ba? Which is this one. Y sub p is already solved at I sub x over a bar y. And so we have here, when y sub p will be substituted, so you have I sub x over a bar y minus the quantity bar y. But take note that I sub x is the moments of inertia of this area referred from this axis. Now, if this moments of inertia shall be taken from its centroid. So if we're going to apply the transfer formula, you still remember the transfer formula for the moments of inertia. That is equal to the moments of inertia about a certain axis is equal to the centroidal moments of inertia of that area plus the product of the area multiplied by the distance of the centroid of that area to the axis x squared. And if this will be substituted here in the formula, let's go back here. That E is equal to Ix over A bar Y multiplied by bar Y. We try to transfer, substitute this with the equivalent formula from the centroid. And that is equal to I sub G plus A bar Y squared over A bar Y minus bar Y. Now, if you are going to simplify by getting the least common denominator of A bar Y, so we shall have here I sub G plus the quantity A bar Y squared minus A bar Y squared, and you will notice that these two quantities will cancel. And what will be left will be the distance E shall be equal to I sub G over A bar Y. And in this formula, we shall be defining E as the location of the center of the pressure below the centroid of the plane surface. Na kung saan yung ating I sub G is the moments of inertia of the area with respect to an axis through the centroid, okay, parallel to the liquid surface. And area is area of the plane, and bar y, again, is the distance of the centroid of the area from the liquid surface measured along the axis of the plane. Mayroon akong gustong ipaunawa sa inyo, no? Babalikan lamang natin yung ating, okay, y sub p. Yung ating y sub p, okay, is equal to this one. Ito yung y sub p natin na I sub x over a bar y. Samantalang yung ating e is I sub g over a sub y. Okay, huwag nating ipagkakamali, ano? Kapag e ang tinutukoy natin, mine-measure natin yung kanyang distance mula saan? Sa centroid, sa makatuwid, ang gagamitin nating moments of inertia is moments of inertia with respect to the centroid. Samantalang ang ating y sub p is this part only, I sub x over a sub y. Saan ba naka-refer ang ating y sub p? Ang ating y sub p ay naka-refer sa x, kaya huwag nating ipagkakamali. Okay, dapat kung naka-refer siya sa x, ang ating moments of inertia shall be taken at that x-axis, which is the intersection of the axis of the plane and the liquid surface. Samantalang kung E, which is referred from G, therefore this must be I sub G. Yun ang simpleng technique para hindi natin makalimutan yung formula for the location of the center of pressure. At para mas lalo natin maunawaan itong ating dinidiscuss na topic, ay mas maganda na solve natin itong tatlong sample problem na inihanda ko to reinforce the derivation of the formula that I have given you. Okay? And here is the sample problem. Okay? Puntahan natin, ano? Sabi dito, find the total hydrostatic force and the location of the center of pressure exerted by the water and the submerged gate if A, letter A, the gate is rectangle having a width of 1.2 meters and a height of 3 meters and submerged vertically having its top flush with the water surface. Second is the gate is triangular in shape with a height of 3 meters and horizontal base of 1.2 meters and is submerged vertically with a base flush with the water. And letter C, the gate is semicircle having a radius of 1.5 meters and a base on top at 2 meters below the water surface and submerged in an inclined position such that the axis is 30 degrees with respect to the vertical. So in this particular problem, meron tayong sample, tatlong cases, ano? Tatlong different figures or different figures that are submerged in water. Okay, the first two are similar in situation but of different cross section, while the third one is different scenario. Okay, medyo nakalubog ngayon siya at naka-incline pa. Para madali nating masundan, unahin na muna natin itong problem number 1. So here is the solution to the problem number 1. Sabi dito, we are solving the hydrostatic force on and the location of the center of pressure if the gate is rectangle having a width of 1.2 meters and height of 3.0 meters having its top flush. Pag sinabi natin flush, kikapantay lang siya ng liquid surface, ano? With the water surface and submerged vertically. Naka-vertical ngayon yung ating plane. And so the scenario looks like this one. Let us try to draw it. If this is our liquid, assuming that the liquid have unit weight of 9.81 kilonewton per cubic meter, ano? So we have here our plate that is submerged, that is flush at the top. Sabihin, the topmost is at the same level of the liquid surface. It is submerged vertically, and here is our section. The section is 1.2 meters by 3.0 meters. Okay, because of this dimension, we expect that here is the centroid, G, which is located somewhere here at a distance of what? 1.5 meters. Okay, you will find that because the plate is submerged vertically, the value of y, bar y, is the same as the value of bar h because the plate is submerged vertically. And so if we're going to look for the center of pressure, there will be this, here will be our center of pressure at dito matatagpuan natin yung kanyang force, yung hydrostatic force acting on the plane. And we can find that hydrostatic force at a distance y sub p mula sa ating center of pressure. Di ba? Solve na natin itong magnitude of the hydrostatic force. We know that using the formula that we have just derived, the hydrostatic force is equal to W times bar H times A, where this W is given to be 9.81. Yung ating bar H is already computed at 1.5 because this is 3. And our area is 1.2 multiplied by 3. So you will notice that itong tatlong unit na ito will cancel each other. And therefore, our F can now be computed to be 52.924 kilonewton. This is the force exerted by the liquid on that part of the plane. And the question is, where is it located? Let us try to find where is it located. Okay, if we're going to solve for the position of the center of the pressure, maybe we can find it in two ways. We can solve the value of y sub p o pwede nating solvein yung ating E. So, unahin natin, if we wanted to solve for the value of y sub p, since y sub p will be referred from I sub x. Ano ba yung ating I sub x na ito? Itong I sub x, itong intersection na yon. Ito yung ating xx na tinutukoy. Ano? At sabi dito, the I sub x will be equal to what? Will be equal to the moments of inertia with respect to this x-axis. And since the x-axis, di ba, coincides with the base of the rectangle, therefore we can find the moments of inertia of the rectangle to be equal to bh cubed over 3. That is equal to 1.2 times 3 cubed over 3 divided by the area, which is equal to 1.2 times 3, and the location of the centroid, which is also the same as 1.5. Sabi ko nga, bar H is equal to bar Y because the plate is submerged vertically. And so you have here 1.5. And if this will be simplified, so you will have a value of Y sub P equal to 2.0 meters. So kung sakali naman, gusto natin solvein yung ating center of pressure, using the distance, of the center of pressure from the centroid of the plane. Mula daw dito. So tawagin natin na yan ay E. So ito yung ating sinosolve ngayong E. And how do we solve for E? E will be equal to I sub G over A sub A times bar Y. Since E is measured from the centroid, therefore, yung moments of inertia must be referred from the center of gravity or the centroid of the geometric figure. So that is equal to I sub G. And what is our figure? Our figure is rectangle. And we know that the moments of inertia of the rectangle at the centroid is equal to bh cubed over 12. That is equal to 1.2 times 3 cubed over 12, dividing by the same magnitude of 1.2 times 3 times 1.5. And so our E becomes equal to 0.5. And you may check, because you will find that the sum of bar Y plus E must be equal to Y sub P. We have computed that Y sub P equal to 2, and we have computed that E equal to 0.5, and we know that bar sub Y is equal to 1.5. Therefore, 1.5 plus 0.5 is equal to 2. That's how we can say that our solution is correct. Okay? Napuntahan naman natin guys itong second problem. Okay? Yung second problem, sabi dito, what would be the hydrostatic force exerted by the liquid if the gate is triangular in shape with a height of 3 meters and horizontal base of 1.2 meters and is submerged vertically. Submerged din siya vertically. And flush with the liquid surface. Gaya ng senaryo, kapantay ng tubig yung base ng triangle. So, pakita natin yung triangle. Ano? Dito na siguro gawin natin, palitan lamang natin siya ng triangle. Ito yung nangyari. Ano? Ang ganda ng senaryo. Ito yung senaryo. Nagpalit siya ng figure. Yung ating figure, naging triangle. The base of 1.2 is flush with the liquid surface. The height is 3.0. Here is the centroid of the rectangle, the triangle, and we know that the centroid is equal to 1.0. So we'll be looking at the value of E, Y sub P, and the magnitude of F. If we're going to solve for the magnitude of the hydrostatic pressure using the formula that it is equal to W times bar H times A. Isa-isahin natin. What is our W? 9.81. What is our bar H? 1. And what's our area? That's 1/2 of the base multiplied by the height. And so when we substitute the value, you will have 9.81 multiplied by 1 multiplied by 1 half of 1.2 times 0.3. Again, these units will cancel. Itong part na ito will cancel. And so your F will be equal to 17.658 kilonewton. That gives us our magnitude of the hydrostatic force. Now, our next concern is to find the position of the center of the pressure. Ipakita natin dito. How are we going to solve for the position of the center of the pressure? We may again refer its position from the intersection, and this is from the XX. So if we will be solving for y sub p, then it will be equal to I sub x divided by a times bar y. And ito yung ating XX, di ba? And the triangle have the same base that coincide with the x. Therefore, we have a special formula for the moments of inertia of the triangle that coincide with the base. And that our I sub x will be equal to 1 bh cubed over 12. Ito yung moments of inertia of this triangle with respect to the base will be equal to bh cubed over 12. Our A is computed to be 1 half of 1.2 multiplied by 3 multiplied by 1 being the distance of this G from that position. Ito yun. Kaya pag sinimplify natin yung ating y sub p, our y sub p will be equal to 1.5 meters. And we can check this value if we will be solving the center of the pressure as by its distance from the centroid of the plane surface. Ibig sabihin, we will be looking for this E. And we know that E will be equal to I sub G over AY. Tandaan, ano? I sub G because the distance will be referred from the centroid. Therefore, it will be I sub G. And therefore, it will be equal to a BH cube over 36 because the triangle have the moments of inertia with respect to the centroid equal to BH cube over 36. Divided by the same quantity, that is 1 half of 1.2 multiplied by 3 multiplied by 1. And this gives us a value equal to 0.5. And if you wanted to check whether you have the correct answer, we tried to find out the value of YP was computed to be at 1.5. Our H is E1 and our E will be is computed at 0.5. So makatwid, yung ating Y sa P is equal to 1 plus 0.5 and that's actually correct. Ganun natin chinecheck yung ating solution kapag meron tayong hydrostatic force on plane surface. Ano? Itong third problem ay medyo interesting kasi iba yung kanyang shape at iba yung kanyang scenario, situation. Inulubog siyang mas malalim at naka-incline pa siya. Kaya puntahan natin itong ating third question. Ano yung third question natin? Sabi dito sa third question, ito yan. The gate is semicircle having a radius of 1.5 meters and a base on top at 2 meters below the water surface. Ibig sabihin itong 2 meters below the water surface, yun yung distance ng top, yung base ng ating gate na ang itsura ay semicircle na kung saan mayroon siyang radius na 1.5. Okay? And it is submerged in an inclined position. Hindi vertically, kundi naka-incline siya. Okay? That the axis is making 30 degrees with respect to the vertical. Okay, para mas maganda ay balikan natin yung scenario. Ano? Ito yung ating axis ng plate. Ano? Yung plate daw natin, okay, sabihin natin ito yung kanyang top, yung kanyang upper base. Okay, na ang distance nito mula sa taas, ito yung lower base, ang distance nito mula sa taas ay given to be 2 meters. Ayun yung 2 meters. Yung sinasabi naman ditong 30 degrees, itong axis na ito makes an angle of 30 degrees with respect to the vertical. Ito yung vertical, 30 degrees. At para makita natin yung itsura nitong ating plane, plane surface, ipakita natin yung kanyang itsura. Ito yung itsura niya. So we have here a semicircle. The radius of the circle is 1.5 meters. Sa makatwid mula dito hanggang dito ay 3 meters. And the location of the centroid from this base of the semicircle is given from most of the table equal to 4 times r over 3 pi. Since our r is 1.5, this becomes 4 times 1.5 over 3 pi. And if this will be drawn back here, ito yung ating G. Diba? At gaya nga ng ating sinasabi, it's very important that the position of this G is very measured from this axis, which will be equal to our XX. Yun, our XX. Ano? So, here's our bar sub Y. Bar sub Y dahil ito ay centroid. And since that is bar sub Y, we can also measure its distance. This distance is also equal to this one, bar sub Y also. The location of this measured from the vertical will be called as bar sub H. Diba? So we would expect therefore that below G will be subjected to hydrostatic force F at a distance equal to E. And this position will be called as center of pressure. Center of pressure. And it is also important that we define the position of this F from the reference x-axis at tawagin natin siyang y sub p. Ito rin yung part nito. Yun. Diba? Kaya ako pinapakita dito kasi mamaya makikita natin paano siya gagamitin. Okay? So, the distance of this center of pressure vertically would also be defined from here, mula dyan sa part na yun. But later on, we shall be defining that. So, we can solve for the magnitude of the hydrostatic force. And the formula for finding it will be the force equal to W times bar H times A. We define one by one. So, we have our W, our bar sub H, which will be equal to this quantity. Let us try to look at this value. This bar sub H will be the sum of the two quantity, which will be equal to 2 plus the vertical distance between A and G. Diba? The vertical distance between A and G, which is equal to AG cosine of 30. If that would be shown here, it will be this distance, kulay red na yan. Diba? Because this is 30, this is also equal to 30, and therefore the vertical distance between AG is equal to AG cosine of 30, and that becomes the vertical distance of the centroid from the liquid surface, and that is equal to 2 plus AG cosine of 30. Diba? Now, what is our A? Our A, this will be simplified, by the way. It will be equal to, 2 times, what is our AG? Itong AG natin is also the same as, the distance of the centroid, and this is equal to 4R over 3 pi. If this will be substituted with the value, 4 times 1.5 over 3 pi times cosine of 30, then bar H will be equal to 2.5513 in terms of meters. Ibig sabihin, itong ating bar H is 2.5513. So, na-define na natin ito, define na lang natin yung ating A. What is our A? Our A is half of the circle, and that is equal to pi r squared over 2. And when that is substituted with the value, we have 1 pi times 1.5 squared divided by 2. And so, if all of these values shall be substituted, ang ating F will be equal to 9.81 times 2.5513 times 3.534, representing the total area. So in here, you will notice that all the units M will cancel. At ang matitira, F will be equal to 88.45815 kilonewton. That becomes the magnitude of this F. Now, if we will be looking for the position of this F, therefore, we shall define the value of Y sub P. Diba? And again, so we can find that location, either using the location Y sub P, or we can simply use E. Diba? So we will be using E, therefore we shall be referring the moments of inertia at G. Diba? So we shall be having here our formula that E equals I sub G over A times bar Y. Now, ano yung ating I sub G? I sub G natin dito is the moments of inertia of the area with respect to the centroidal axis that is parallel to the base or with the water surface. Not with the water surface, but with the centroid that is only parallel. Ito yung part nito. Kung dito natin yan, yun. Ito yung parallel to this one. And the value of the moments of inertia from the table that we have is equal to 0.11 r to the fourth. Kaya yung ating I sub G is 0.11 times r to the fourth, na kung saan yung ating r will be 1.5. Ano naman yung ating A? Bar Y natin. Yung bar Y natin ay itong position na ito. Location ito, papunta doon, di ba? Yung ating bar Y, kung dito natin, kung ipapakita itong triangle na ito mula sa X papunta sa E. Di ba? papunta sa G. Mula dito hanggang dyan. And that actually is equal to what? Okay, bar sub H. Okay, tingnan natin itong triangle na ito. Okay, so you have bar sub H. This angle is also equal to 30. Bar sub Y, we are looking for bar sub Y. So we can find for this by using the relation that the ratio of bar H to bar Y is equal to cosine 30. And therefore, bar Y is equal to H over cosine of 30. Pwede yung gamitin na. And so if we will be substituting that value in the formula, our E will become equal to 0.11 times 1.5 to the fourth, A divided by the area, which is computed to be 3.534, and A bar Y is equal to A bar H, which is already computed to be 2.5513 over cosine of 30. And so if this will be simplified, so we shall be having the location of the center of pressure measured from the center of the gravity equal to a 0.0535 meters. So guys, yan ang ating sample problem, at sana sa pamamagitan ng tatlong problems na pinakita ko sa inyo ay naintindihan ninyo yung application at paggamit ng derived formula of the hydrostatic force on plane surface and their position, either measured from the centroid or measured from the intersection of the axis of the plane and the liquid surface. Guys, once again, thank you very much for watching.